In this video, we are going to see how to derive the first and the second kinematic equation. So let's look at the first equation. To derive the first equation, we are going to start with the relation between the velocity, change in velocity, and acceleration, which is given by change in velocity is equal to integral of a dt, where a is the acceleration. And we are going to take the limits as 0 to t, assuming that the object is starting from time t equal to 0, and we want to analyze the motion at some other time t equal to t. Acceleration is constant, so it will come out of the integral sign and we are left with dt. Delta v is change in velocity, so we can write it as vf minus vi, and integral of dt will give us just t, because we know that it's 1 dt, and the number 1, when you integrate it, you will just get t, and you are going to integrate from 0 to t. The limits, when you substitute, we are going to get it as t minus 0, which we can write as at. This can be then arranged into our known form of first equation, which is vf equal to vi plus at. So that's the derivation of the first equation. Now for the derivation of the second equation, we are going to start with the relation between displacement and velocity. So we know that delta x is equal to integral vt dt, and we are going to again take the limits from 0 to t, time from t equal to 0 to time t equal to t. That means at any given point of time we can find what's the displacement. Now this vt can be replaced using the first kinematic equation. So first kinematic equation was vf equal vi plus at, where vf is the velocity at some given point of time, so vt. We can replace that vt into our equation as vi plus at, and then we can integrate. So vi is a constant, it is the initial velocity. Vi is a constant, so it will become vit. When we do the integral of a constant, we get it as vit, and for at it will be at square over 2. Now if you wish, let's just quickly recall, t to the power of 1, for at it's t to the power of 1, so we can use the integral formula, which is t n plus 1 over n plus 1, so we get at square over t, and vi is actually t to the power of 0. So I'll just show you, this is t to the power of 0, so when you do the integral, it will be 0 plus 1, so t to the power of 0 plus 1 over 0 plus 1, and that will give us t. That's why we get it as vit. Then we can put the limits and then open the brackets with the limits. 0 will give us 0, so we reach the final equation, which is the second kinematic equation, which is delta x equal vit plus half at square.